Ladies and gentlemen, thank you for waiting. We would now like to begin the third session titled IBM Watson Question Answering System and Cognitive Computing. Please welcome Dr. Koichi Takeda, Distinguished Engineer of IBM Research Tokyo.
Good afternoon, everybody. It's my great pleasure to be invited for an introductory talk on IBM Watson QA system and cognitive computing. I knew I would look like a salesperson here at this conference, but I felt obliged to behave like an ordinary IBMer. More ordinary IBMer than those people sitting in there, it's IBM people there. But I'm a researcher at the Tokyo Research Laboratory, and I'd like to share the excitement of the grand challenge for the making the computer to compete against the human champions at the Jeopardy quiz show. And after that challenge, we were successfully making the technology into business, cognitive business. So let me start the mission statement. About more than 10 years ago, when IBM Research was to have some new project for kind of capitalizing the 100th year of the IBM Corporation in 2011. So we are about to choose the next big thing after the Deep Blue challenge against the world chess champion Kasparov. So that was the mission statement approved by the lab director Paul Horn. But that sounded too difficult for a researcher. So nobody really volunteered to do this work for about 2 years. The grand challenge opportunity is so rare that it happens every 10 years or 15 years, and that was a very, very challenging thing. So we had kind of a wow factor so that everybody, non-technical people, can understand the importance of the technology. And popular games are one of the favorite team because IBM used to challenge checker champions and chess champions. So popular games are one of the favorite themes. So Jeopardy was naturally thought of the 21st century grand challenge because the huge amount of digital data has been accumulated. So we want to prove that that amount of data will be turned into the capability of doing the intelligent tasks like answering the quiz. So we kind of wanted to have the scientific impact as well as a business impact. So that was to make the question answering technology into the areas like medical diagnosis support or recommendations or contact center support. So those are in the original idea of the making the grand challenge of a Jeopardy TV quiz show. And about 2 years after, around 2006, the leader, Dave Ferrucci, decided to do this task, and he persuaded his team. They were doing some government project called Acquaint for the question answering challenge. But the leading edge technology was probably fall short of the challenging against the human champions. So we came up with we needed to come up with the totally new architecture and the algorithms. And the Jeopardy quiz questions are kind of conformed as the entertainment TV program, so the audience can enjoy solving the given questions. So the expressions are very much sophisticated. It's a very complex language comparing with the newspaper articles and the ordinary English text. And the subject of the questions are open domain, so you can question about anything. That was one of the toughest situations. We have to answer the questions in all domains. And accuracy is important because we are supposed to compete against the champions. the accuracy should be around 90% when you press the button. So those are the challenges. And we kind of skip the hard work. But in 2011, February, the TV matchup was on air. So let me just show you the movie making of the Watson.
This is Jeopardy! The IBM...
Here, this is the ordinary, different from the ordinary Jeopardy opening because the background of the building is IBM Research in the Yorktown Heights. Because we didn't want to move the Watson computer to the TV studio, they came to IBM Research to build the studio because so that we can kind of stably run the computer in here. And so that background is very special. Of course, we have the CEO, Sam Palminado, back then, and everybody, all the executives are there in the audience. So we are really kind of had a strong pressure so that Watson can at least perform well against the champions. So on the left-hand side, that's the Ken Jennings, who has the 74 winning streak in the history of Jeopardy. So it's the longest winning streak. On the right-hand side, that's Brad Rutter, who earned more than $3 million, I think it's the amount of prize money. So those are the probably undoubtedly the two strongest champion in the history of Jeopardy. They kind of agreed to compete against the Watson computer. So let me go.
If you're ready, make your first choice.
Let's take alternate meanings for 200, Alex.
4-letter word for a vantage point or a belief.
You got the answer?
Right.
Okay, so the 4-letter word for vantage point or belief. The word, a 4-letter word who has a meaning, two meanings, alternate meanings. One is the vantage point, and another meaning is the belief. So you can see on the bottom of the screen, the TV audience could see the Watson computation, and the top 3 candidates is shown in the lower bottom. So Watson compute that viewed to be the most likely candidates with a 70% confidence. And the second and the third candidates are also in the 4-letter word. So Watson correctly interprets the constraints in the question, 4-letter word. Then look up the dictionary or some similar information source to find that the view has really the similar 2-word meanings. So the computation gives the 70% confidence. So over the 50% of the confidence, Watson thinks that it has found the correct answer. So try to press the button. But the Brad Rutter was faster, quicker to press the button. So although Watson could compute the correct answer, it did not earn the prize money for this question. Okay, so that kind of competition went on for the 122 questions in 2 games. And as a result, as you see in the screen, Watson had the more than $77,000 prize money. That was more than 3 times of the human champions. So that was a decisive win. But I would say that Watson is not 3 times more intelligent than those champions. We had somewhat favored by the length of the questions. If it's shorter, probably humans can instantaneously compute or maybe press the button first and then think about the answers. The humans can do that, but Watson can't. So the longer questions somewhat favors Watson. And there are several game strategies. So all those things beyond the question answering capability gave Watson some advantage in these 2 games. But it may be in a different result when the questions are easier or shorter in many other situations. So we were encouraged by the accuracy of the Watson QA. That was 88%, the same figure with the Ken Jennings in that 2 games. So that gave us the confidence for moving forward with the Watson technology for the real problems and the real domains. So let me give you some technical background of the Watson's computation, how Watson compute the correct answer for the given question. it conforms of the 4 steps, like over here. This is the category of the question and the question itself. Only humans can give the answer for this original format. So we need to do the question analysis first to extract all the content words, the keywords from the category and the question, like dial, dialects, Maltese, borrow, words. All these nouns, verbs, adjectives, content words are extracted to make a bag of words. That's the very, very common strategy for analyzing the natural language text. And that's not enough because it's a very kind of a crude approximation of the subject of the question. We need to have a little bit more kind of a specific information about the correct answer. And that word relation, like Maltese borrows from Italian. And the answer is Semitic language. The instance of the type Semitic language should be the answer. And then it is a descendant from Maltese is a descendant from that language. So those word relations will give you the specific constraints over the correct answers. That was the first step, the question analysis. Then we form a query, information retrieval query, to get the candidates of this question against the information source, including the Wikipedia, Newswire, the encyclopedia, a lot of classic literatures and songs, lyrics of all the songs in the world, and the entire body text of the Bible. Because those kind of pieces of information are often cited as a kind of citation query in the Jeopardy quiz. So that kind of a body of the texture information will be used to give you the candidates for this question. So we retrieve hundreds of candidates by using the search query as a set of keywords, 300 to 500 keywords as the candidate of this question, and that's here. And each of these candidates might be the correct answer. So we kind of insert each candidate into this answer specification part. So maybe Latin is the Maltese descendant from Latin, or Arabic, or Spanish. For those kind of hypothesis is generated for each candidate. Then we form another information retrieval query for this hypothesis. This time we retrieve a set of passages, paragraphs with a lot of keywords and kind of hypothesis inside. So that means high density of the kind of extracted keywords and word relations. Those passages would serve as evidences of the hypothesis. Actually, the Maltese is descendant from Socio-Arabic. So Arabic is the strongest evidence to be the right answer to satisfy this kind of a hypothesis. So that is converted for the kind of a coherence between hypothesis and the evidence, and the number of such evidences are converted into the numeric score, so that the candidate with the highest score would be closest to the right answer. And we estimate the confidence because we kind of knew that the threshold when you find the right answer will be a certain amount of confidence. If you fail to analyze the question correctly, or you don't have enough information in the information sources, the score will be lower. So we kind of set the threshold so that we can confidently make the accuracy of the answering the correct ones. So in this case, Arabic is the correct answer. So that is the computational things. And you can think about the usage of this method for example, diagnosis support. In this case, the question would be the patient symptoms, the patient descriptions. And you can retrieve, you can rank the past doctor's decisions or medication or surgery or tests associated with the similar patients, with the similar symptoms, you can kind of reconstruct the decisions by human doctors with this computation. And also you can do this recommendation. If you put the consumer profile over here, like want to kind of do the investigation, investment into the kind of financial products, but doesn't like the risky ones, then you can like national bond to be the appropriate choice of the product. If it's associated with the actual purchase or satisfactory customer satisfaction score, you can kind of recover the similar decision making by this computation. So recommendations, diagnosis support, call center applications, all those applications are run by the similar ideas of the question answering. Okay, so that's how Watson has been converted into the real world. But that is only half of the Watson story. Another half is how to train Watson. This is the equally important thing, because you have the software hardware system Watson, but without the training, it cannot perform well. It will not make the correct answer mostly, because it doesn't know how to score, how to weight the evidence and the hypothesis and all those aspects into numeric scores. So we ran Watson with the 25,000 past Jeopardy questions. And for each question, Watson scores the candidate, but we know the correct answer because it's the past questions. We already know the correct answer for each of the past questions. So we kind of tell Watson to kind of change the matrix weighting scheme so that the correct answer to get the highest score for most of the time. So that was how you do this machine learning training for this scoring scheme. We tried deep learning. We tried all the machine learning techniques, support vector machines, and it turned out that there were not much difference between those machine learning techniques. And we kind of came up with the logistic regression approach. And this is very good because that approach will tell you which evidence contributed to the score. So we can trace back to the evidence of the score, I mean a candidate. And that is very important for a doctor to make the informed decisions by using not just the answers, but the supporting evidence. The recommendation is as well. You can tell why you recommend this particular product based on the evidences. So that is practically very, very important advantage over the deep learning techniques, actually. Okay, so that's a story about the technical side of the Watson computer. And one software engineering aspect was also important. We kind of built the system on a development environment called UEMA. It's now open source from Apache. Watson is made as about 300 plugins over UEMA architecture. We worked together, about the people, 30 researchers worked together for kind of checking in their, modifying their own components. So that was very important for the kind of synchronous update and see the improvement of the accuracy. So that helped a lot. And actually the researchers in the Yorktown Heights worked together in the same laboratory all the time. I mean, from the morning to the midnight, they work together in the laboratory to share their problems and instantly get the answers from others. And those highly collaborative environment helped the kind of finish this project. It took 5 years, but it was quicker than we thought. We thought it could span 10 years or so once before we kind of really win against the human champions. But the amount of information was more than we expected. The growth of the Wikipedia and digital information was enormous. 95% of the Jeopardy question had headings in the Wikipedia entry. So that was huge. and the power of the digital information for such intelligent computation. Okay, sorry. So in 2011, we had this kind of a rewarding moment. That project was the globally organized research team. The main people are here in the Yorktown Heights, but from China, Tokyo, and Israel, we kind of had global collaboration for making this happen. And I didn't work quite well. I mean, I didn't contribute the code to the Watson system, but this guy, I worked with him, Kanayama-san, made a very important contribution to the type coercion. That is the answer type and the real candidate matching with respect to the category of the entity has to match, will give you the strongest support of the right answer. He contributed to give the data for the human candidates or country candidates or Nobel candidates. Those different entity types would need different evidences in the Wikipedia and the information sources, and Kanayama-san provided that information ready for the computation. So that is probably one of the largest contributions from the Japan team. And but that was, anyway, the global collaboration really made this happen. Okay, so that was 5 years ago. And during these years, IBM decided to make this technology into the cognitive business and grow as one of the core business pillars within IBM. And until maybe last year, we did not realize, but we are facing the very different disruption in the industry. Just Hirai-san gave his talk. The sharing economy makes the very different, very strong change in the industry, because the Uber is the taxi company, the world's biggest, but without any real taxi asset itself, but they kind of a contract with the individual drivers. So, and similarly, Airbnb has no estate, but the largest accommodation service company. What that means is that the cyber-physical balance is changing a lot. Traditionally, the largest industry, the largest company in the industry has a physical real estate or whatever physical assets as the kind of major weapon for the business. But now, the cyber part, digital information plays a key role for this growth or the leadership position in the industry. And that should be captured for the important aspect of the new industry and the digital disruption. The size of the data is enormous. Oil and gas, public safety, healthcare requires petabytes of data. A weather company, IBM, acquired the weather forecasting capability through the millions of data points around the world. So that is the data-centric, big data-driven IT infrastructure for across the industry. So that's probably driven by the cognitive system like Watson. So you have three important elements in this business: data, API economy for flexibly composing the wide variety of industry solutions, kind of a long tail business spread. And then the intelligent computation supported by cognitive computing or artificial intelligence makes the industry disruption. So let me switch to the healthcare industry. In the United States, it's been reported that every 5 years, the information doubles. And typically, the medical journals, about 1 million medical journals are published every year. And typically, doctors can only read 300 to 350 papers every year. So that is a huge difference. And once you think about the genomic precision medicine, mutations. That kind of information will be more than you can handle as the ordinary and the traditional medication and medical treatments practices. So that would end up with the misdiagnosis or longer time for the treatment or more cost for the treatments. In the worst case, the patient might die because of that kind of inefficiency or incorrect diagnosis. So the cognitive system would help the help the doctors to make the best or correct decisions by giving the appropriate, relevant information from the huge amount of data around the doctors. So that is the original idea. And so the medical application, the input is very, very complex. The diagnosis and the patient description is much, much longer than the TB Jeopardy questions, and including the positive and negative expressions. And that is very, very complex again. If you fail to capture the negated information, that is the totally opposite information you capture from the patient description. And it is fatal for you to make the right decisions. So the positive and negative information extraction is very important. Then you can get the family treatment and the history of the patient treatment and the vital signs. All these kind of different types of clues will be gathered. Just like a question analysis, you do the patient analysis to get the extracted information. Then the trained patient model will give you the most likely disease or most likely test cases and so on. So that's basically the same as the question answering for Jeopardy, but would be more efficient for the doctor's domain. And the first medical institute tapped IBM was the Memorial Sloan Kettering Cancer Research Center in New York. And they thought that the Watson capability would make the best tool for the doctors to catch up with the latest information for oncology. We had actually a good amount of the information source. The Medline medical citation, that's about 26 million medical citations published ever in the medical domain. The National Library of Medicine in the United States will allow you to use the citations for free. And we have guidelines, the drug information, adverse effect, and adequate medical record for the patient within the medical institute. All those pieces of information will help you to kind of draw some good information source for the useful insight. But the problem was to come up with the training data. What would be the training data for the medical Watson? Nobody had the answer. IBM didn't know that because the researchers only tried the Wikipedia, Jeopardy challenge, no real use cases yet. The doctors have no idea because they haven't had the system like Watson before. So we have to come up with the best training data so Watson can train. And it settled down with the use case data, like doctors do discussions on the case-based discussions. So make up the patient case and make the available information to draw some of the promising treatment and necessary tests and medication. So that kind of information to train Watson through the repetitive feedback from the doctors. Actually, when we kind of announced this use case in 2013, doctors spent 5,000 hours for logging in the system to give the correct data to Watson. And to date, in the year of 2016, the logging the amount of users logging hours exceeded 13,000 hours. So that's huge effort for kind of making Watson reliable for doctors. But that was the first case. We are now improving the kind of a medical healthcare application. So let me give you some ideas how the doctors wanted to train Watson. So this is the use case. For example, that's too fast. This is the use case for the patient, the lung cancer patient, female patient, without the smoking habit. So how do you extract key information, patient summary, and necessary test and possible medication candidates? So Watson will give you that this typical patient has the CTI scanning data of the cancer size and location. But it says you need to have the pathology of the patient, because you need to sample the genes because you have to analyze the mutation of the genes to decide which cancer treatment would be necessary or maybe best. So without the smoking habit, the lung cancer might come from some mutation of the gene. In this case, you need to have a different drugs or the treatment. So that test would be probably necessary for this case, and that is one of the point. And the doctors asks for the evidence for this kind of a recommendation, and it refers to the NCCN guideline, where it says for those patients without a smoking habit for the lung cancer treatment, you should consider the test of the genes and so on. So that informed the decision will be making the doctors for the correct treatment. And that system was first deployed by Memorial Sloan Kettering, but soon replicated at the Bumrungrad University Hospital in Thailand. And it's now replicated in India, in Korea, and will be soon replicated in China. So that means the North American practices and the guidelines and the insight discovery are now leveraged in the Asian countries, and will be probably localized to give the best treatment insight discovery for the Asian patients. And it would be somehow related to the hospital management and probably medical tourism also, because they are tackling the improving the quality of the healthcare. That would be very good for the making their mind share among the patients, considering the which hospitals to go. So that would be important too. Now, Cleveland Clinic uses Watson for the educational system. The students have to pass the US medical licensing exam to become a doctor. And Watson might help the students to efficiently acquire the knowledge for the passing the exams. So that is the original idea. And here, the
U.S. spends $2 trillion on healthcare annually, almost 30% more than any other country.
I was kind of, it's noisy. So the original question is a 70-year-old male with a heavy smoker and 4 weeks of the post-total prostatectomy and other symptoms over here. So would you kind of think about the pneumonia or the heart failure would be the case for this patient? With the two choices, what do you think is the kind of situation, the problem? And this particular combination of the disease and symptoms and the factors are too specific. So if you give this kind of entire question as an input to the Watson, you cannot find a lot of useful information. So what we do is to decompose this description into 6 major factors over here in the yellow characters: heavy smoker, prostatectomy, low fever, and so on. So giving 6 queries to Watson, what causes, for example, what relates to the heavy smoker, and what causes a heavy smoker, what caused by the heavy smoker, and so on. That question will give you the related factors or many other incidents and symptoms related entities. So you can draw to the 2 diseases over here, pneumonia and leukemia, and the one which connects to the as many as the 6 symptoms will explain as the most likely disease candidate, right? So this is the idea. But if you just give the 6 questions, it is only the direct relationship to the disease. But after you repeatedly make questions from these white boxes, what causes the indirect factors like that, then you can draw some indirect relationship from the disease to the all 6 symptoms here. So in the first looking, pneumonia might be the more likely disease, but after all, you can see that that heart failure would be more likely to explain all these factors. And by clicking the link between the boxes, you can go to the original paper describing the relationship. So that's how you can be supported to pass the licensing exam. This idea is the use of the Bayesian network from the encyclopedia knowledge and static knowledge. And you need to probably improve the kind of a relationship with a statistical plausibility. So you can gather, for example, this is the actual 300 patient records in the medical, electronic medical records, similar to the patient described in the question. By looking at the pathways, which medical medication will give you the best outcome will be numerically, statistically predicted here. So by combining the encyclopedia knowledge of Watson with the real data mining pathway visualization from the medical records, the doctors can be harnessed with both ways, the static knowledge and the dynamic data mining information for giving you the best treatment plans. Okay, so that's the kind of healthcare use cases. Another one is the chemical drug discovery. If you give a question to the drug discovery situation, the Watson should not be giving you the right answer because you don't have to recreate the same drug in the future. So in this case, if you are making a new product, Watson is supposed to give you only the relevant information, but not the right answer because it shouldn't be existing. In this case, the chemical compound has to be ingested. So that you can give you the similar chemical compounds and the possible modification of the chemical compounds to give you the new drug. So that is the domain adaptation, not just the clinical information, but the chemical information to give you the drug discovery support. And the last one is the genomic information. It started as in the New York Genome Center to tackle the brain cancer. And once you do this sequencing of the patient gene sequences, the Watson will give you the report of the drug, the applicable FDA-approved drug list and the approved drug for the different organs. And those are the candidates for the doctors to be giving to the patient. And also this circle shows this particular gene mutations within the patient. And so by combining these particular genes with a kind of a list of possible drug, you can combine the particular combination for giving you the best treatment result for the particular patient. And this use case will be explored by about 20 medical institutions in the world. And one of the early adopter is the Tokyo University. They are now using this system for the evaluating the system for the research of the precision medicine for leukemia. And recently, there was one finding using the system to find the correct, better drug medication to cure the one patient. That was broadcasted in NHK. So by accumulating those kind of evidences, doctors in the future would think about Watson for genomics would be the vital tool for driving the precision medicine. New York Genome Center also published a paper with using this Watson for genomics to make new treatment ideas for the brain cancer. So we are kind of generating the good evidences for using Watson in the medical treatment. And we are also acquiring the companies for getting the patient data and the health data. By acquiring 3 companies, including Truven Health, we are now capable of handling 300 million patient lives as a collection of the data. So that's huge accommodation of the data to be applicable for the analytics service. Okay, the second use is the call center and the self-help. The younger people will not call the contact centers, so we can probably give you the line bots for helping them for everyday queries in the university life. And that is in production in several universities. And some students think that the Watson agent to be the human. So in particular use cases, it gives a very good answer for the probably frequently asked questions. It's now available as a Watson virtual agent. More professionally, you can have the financial advisor to get the help from the Watson for the best candidate of the financial product to be recommended for their clients. In this case, Watson is only a part of the dashboard. So you can have a broader decision from the financial trends and market news of the day, all the necessary information to be ingested by the financial advisor to give the best recommendation for the clients. Okay, interesting part is the personality insights, because the customer satisfaction depends on the nature or characteristic of the individual clients. So we analyze those tweets or emails for a particular client to judge their personality, general personality dimensions in the 5 dimensions. That is one of the important move to understand more of the clients to give the best AI services. Now finally, the cloud environment, you have APIs in the cloud, and that will help the developers to build their own ideas, like a conversational shopping helper, or Cognitors, which is the plastic dinosaur toy for helping the kids to learn about the kids to learn their interesting topic ranging from the science to the literature and so on.
That's a lot! What is 2 plus 2?
4.
Awesome job, Grayson.
So this was very interesting because the idea was recognized as the best proposal. The proposer wanted to make the business from it, and they published the idea in the Kickstarter to fundraise. And they kind of actually successfully start selling that toy this July. You can buy it from Amazon. And then the robotics will be also the conversational robots to guide you to the operations and so on. So that's one of the very interesting areas where you have edge computing, the intelligence services to the customer for healthcare, wellness, and chronic disease treatment and so on. The number of developers are growing, huge. Because of this particular cloud services. You can log in and have their account for free service for 30 days on IBM Bluemix. Okay, I have to skip a little bit, but this is a cognitive computing. You can combine the hardware technology and the software technology to build something like a human-like system to build an intelligent system with a lot of deep learning and pattern recognition and the inferencing capabilities, now is a very interesting time for you to probably come up with the innovative system inspired by the human behavior. Thank you very much.
Thank you very much, Dr. Takeda. Well, we're kind of running out of time, so if you have any questions, Mr. Takeda will be available during the break, so please grab him and ask him questions. Thank you very much, Dr. Takeda.
Thank you.